So we have discussed about all these things, but one thing is still left, that is the conflict present in case of CLR1 item. Okay, conflict present especially in case of LR1 item. So let's see, let's try to dive into the topic. So you will first, what we will do is SR conflict in LR1 item. So how we can understand this one? So let's take a very simple example again so that you can realize it. So for example, like this, I have a production rule A2 alpha dot A beta, whose uh, look ahead is, say for example, C or D, and because of this, okay, I have a small, it's a terminal, so I don't need to find any closure of this, but I have another production rule here which contain a final item. So for example, that is R dot. Okay, which is basically your A, or say for example dollar. So with respect to the lookup, basically you will see there is no difference, right? But as I told you, according to the logic, since we place under the look ahead, so one thing is, you see that from this point, what I can do, I can, if this is in a I0 same I state, as we have seen, we have explained here. So this is I state, and I can jump from I to another state because of the small a, right? And I will write here a to, say, alpha a dot b dot beta comma c or d, like that, right? This is my another state, sorry, say this is ij. So with respect to table, if you see how it will reflect on the table, if you look into the ith row, maybe I have a b, okay, and dollar is my in the action part, and something present in go to part which is not important. Now because of this small a, from ii to ij, what I will write under small a, I will write sj, I will write sj, right? Now one thing at the same time, since this b contain final item, and this, because of this final item, I have to write reduce move. What we know? We know that we don't put reduce move in all the column, but under the look ahead only. So that means this b to r, if I say that b to r, this is some say pth production rule. Okay, rule number p. This rule number p will be applied under dollar column as well as under a column. This reduce move, because these a and dollar are the look ahead. So, and that is why you will see that we have a SR conflict, right? So this can be a situation for which I can get an SR conflict. That means if someone asks you that just find out whether I have an SR conflict or not, just closely watch one thing. In first of all, I told you already in my previous classes that if whatever conflict it may be, at least one reduce move has to be involved. Because S R R R, that means one R is present at least. That means at least one reduce move is there. That means if someone asks you about to find the any conflict, first thing that you have to identify what are the states where reduce move are present. Now from those set of states, concentrate on those states where other than the reduce move, any other shift move or any other reduce move is also present. And that might be a source of a sub conflict or other conflict, right? And in case of a LR1 item, whatever it may be, CLR1 parser or maybe LALR1 parser, if you see whatever present after this dot is same as the look ahead for the reduce move, that means definitely you are going to get a SR conflict for that reason, right? Now this is what we have discussed SR conflict, right? So now if I consider RR conflict in CLR item, what I can find out, let's take a again same example, almost same example. Like I have a some ith state where I have two production A to alpha dot, I have A or B, A B to beta dot A. That means I have same look ahead. So naturally what I will have, if you look into the production in the table A, B and dollar, and if you consider say it's ith row, okay, assume that I have not only A, it is A or B. Okay, A or B, just for timing we are considering. So because of this A to alpha, this production, this final item, I will get, suppose that A to alpha is a RIth production rule, sorry, RPth production rule, and B to beta is RQth production rule. Okay, so I will write RP here. At the same time, because of this V to beta, this is also final item, I have to write RQ in the both cases, and as a result, what you will find out? You will find out we have RR conflict. So that means if I want to check whether I have an RR conflict or not, first of all you have to check what are the states where two produce move are present, and then you have to check whether the lookup of both produce move is common. Is there any common or not? If there is a single common character present in the lookup of both produce move in the same state, then definitely you are going to get a RR conflict for that. Okay. So that means if we have any number of SR or RR conflict in any state, then we can say the grammar is not CLR1, right? I mean, what I can write here, that if we have any number of, sorry, if we have any number of RR or SR conflict in any state, we can say the grammar is not CLR1. Now you see CLR1, if you compare CLR1 table with LALR1 table, LALR1 table is much squeezed. It has, basically merging some states. So naturally, if you find if you find conflict in larger table, in merged table, definitely there will be some conflict, right? So that means if the grammar is not CLR1, that implies, this implies this implies the grammar is not LALR1 also, right? But can I consider the opposite scenario? Like if I have something LALR1 is, I have some conflict in LALR1. I'm sorry. If I find that a grammar is CLR1, is it really possible that grammar will be LALR1 also? Let me check it. Let's take a simple example over here. Okay. So assume that we have a production rule here. There are two states in CLR1 table, in CLR1 state diagram. One is A2 alpha dot comma A, and B2 beta dot comma B. Okay, this is one state, some state in a CLR1 state diagram, and there is another state, that is A2. Let me draw it here, this side. A2 alpha dot B, B2 beta dot A. The states that I have drawn are the states on the CLR1 state diagram. Okay. So with respect to CLR1 state diagram, you see these states are somehow connected. I'm not interested for their connection. Okay. But what thing is present here, that in these two states, the states are same with respect to LR0 item but different with respect to LR1 item. And this already we have seen in our previous example also, right? Like over here. I3 and I6, I3 state number I3 and I6 are same with respect to LR0 item and different with respect to LR1 item. That means the look ahead. So the same thing here also. So with respect to CLR1, no conflict. So that means if I just remember this point, that in this situation, no conflict, in CLR1. Now if I want to corresponding draw, if I want to draw the corresponding LALR1 parsing table or LALR1 state diagram, what we know? That we basically merge those states which have same with respect to LR0 item and different with respect to LR1 item. So what I will do? I will basically merge these two states, obviously, because they have the same property. And as a result, what will happen? What I will get? I will get A2 alpha. I'm merging them means what? I'm merging their look aheads. That means A2 alpha is merged and their look ahead will be merged. So there will be possibility A or B. Similarly, at the same time, B to beta will be merged. And here also I have B and here is A, so it will be B or A. So these become the new merged states for LALR1 parser. Now you see, we have already seen this type of situation that here because of this same look aheads, I have two final items and same look ahead for them. I will get RR conflict in LALR1. Right. So from this example, what basically conclusion we can draw? We can write that a grammar is CLR1 that does not imply the grammar is LALR1. Right? But in other side, a grammar is not CLR1. That definitely imply the grammar is not LALR1. So understanding this relationships may be going to be vital for solving some small questions on observation in this subject. So we have to, I hope now you can understand that basically you need a lot of practice if you want to crack some good competitive exam. Anyway, so we can stop the class over here. So basically the part of compiler, the part of parser design is almost completed. We have seen various parsers, how they works, how it can be designed, how to find conflict and a lot of things. And now basically we'll go for the next phase of the compiler, that is semantic analysis. So we'll do that from the next day. Anyway, so we can stop the class here for today. Bye.